Hello everyone and welcome you all for today's class. Today I am going to discuss about energy storage system and materials because you know that why energy storage system and materials are important. We know that we in solar energy when we use solar energy for two cases, whether it is a photovoltaic mode of energy harvesting or photothermal. We can absorb solar energy directly, we can use it without any transformation, or we can store in form of heat energy, that is photothermal, and we can store directly, we can convert solar energy by using photovoltaic, means direct conversion of solar energy into electric energy. These are modes of energy. But why energy storage is required? In both cases, whether we are using photothermal mode or photovoltaic mode, we have to store it because we know that energy available from solar or any other source, it is not a continuous and having fixed intensity, or you can say power density varying with time. For example, sun from rise to the setting of the sun from 6 a.m. to 6 p.m. There is a variation, and we get peak value of solar intensity between 12 p.m. to 2 p.m. and in the start time it is varying. That's why sometime due to cloudy days it is not available, due to rain overcasting it is not available. That's why it is intermittent in nature. That's it is intermittent in nature, मतलब कि वो क्षणिक हो सकती है, change हो सकती है, that is known as intermittent. And so to maintain its availability during peak time, during use, during load time, we have to provide it by using energy storage. So that's why we are going to discuss what is energy storage and how, what are materials used in energy storage system, making design of energy storage system, and capacity of energy storage system depend upon the size of the energy storage system and the material type, because you know that energy availability is ranging, temperature ranging from 0 to up to 500 600 degrees centigrade. So availability, what kind of requirement is there? For example, for heating purpose, for bathing purpose, for water heating purpose, we need energy at the temperature range from 50 degrees centigrade to 100 degrees centigrade. For example, flat plate solar collector and concentrating collector, more temperature we can get, and further we use parabolic disk collector, paraboloid collector, and heliostat of the reflectors. So energy available at different temperatures. So different types of materials are also required for design of the energy storage system. So first we see that what kind of energy storage systems are required. So depending upon usage, if you draw a graph, schematic diagram, this is a collecting system, this is a collector system, and we get energy from here. We get solar radiation, and energy we can transform solar radiation and we store it here we store it, and simultaneously we can use it simultaneously. This is storage tank and to load for application purpose. This is a one circuit. Here we are getting solar energy from sun radiation. Here we can see we are storing it and we are also using it. So two fluids are there. One is a carrier fluid, one is another. Here is a heat exchanger. So heat will be taken away to the load. So this is a one kind of description of the solar energy system. But it is very simplistic diagram, and there are various very complex type of energy storage system are available, and for different materials depending upon the what kind of load requirement. If load requirement is generation of power, then a heat energy storage system at very high temperature required, and for that temperature different what are materials which can withstand the high temperature and provide energy at very high temperature. So these are depending upon the application, and duration also is very important. What duration you want to store energy. So duration That's why we want to discuss here different types of energy storage system required. This is a symbolic diagram of the energy storage system. Let us see energy storage requirement. Energy storage requirement. Let us मिलाज करते हैं इसको. Energy storage requirement. So first A and this is a B and this is a C. Energy storage requirement. Here QU useful heat gain and Q load. QU and Q load. QU and Q load. Here is the time 0 to 6 and 12, 18 and 24. 0 to 6, 12, 18 hours and 24 hours. Here January 1, June and yearly and December 31. So first one is a buffer type energy storage. A is a buffer type energy storage. Requirement, for example, when whole of the day energy requirement is for the only peak hour. Suppose for 2 hours only. This is energy requirement, and storage will be graph 1 will show storage. This is graph 1 and this is graph 1 and this one is a load. Load is here like this. This is a load. So this is a buffer type energy storage. Our whole of the day there is not a continuous energy requirement. Load, this one showing graph to load. Load is from load and storage time is different. Storage is starting from 6 a.m. to 18, ending at 18 p.m. during whole of the day. But storage huge load requirement starting from 8 p.m. 8 a.m. to 5 p.m. So this is known as a buffer type. We require energy storage only for that time. This is a buffer energy storage. And now a second one is a diurnal for whole of the day. The whole of the day energy requirement is like this. Energy requirement is like this. This is like this, and here requirement is high. Then again requirement is low. This is for whole of the day. This is whole of the day energy requirement, and storage is like this, because storage will start here reaching peak. This is storage because storage will start at normal time 6 a.m. to 18, between 6 a.m. to 18, not beyond that, because normally there is sunset at 6 p.m. And third one is a for energy storage requirement for whole of the year. So requirement when whole of the year, load requirement remains almost constant. This remains almost constant for whole of the year. This remains almost constant. And energy storage जो loading होगा for whole of the year, energy storage system will like this. It will start like here. From June it is starting and lowering here, because we know that generally more heat is available from month of June, and it will decrease in month of starting January, because these are generally cold season. So cold season energy availability is less and it is increasing as temperature rises. And from June to December, before June to December, this will be like this, reaching here like this. So this is a yearly type of energy storage for whole of the year. So these represent very big energy storage. This is very big energy storage, and this one is a medium energy storage. This is very small energy storage, because only 2-3 hours you need energy storage. That is known as a buffer storage. For whole of the day you need energy storage. So this is a medium kind of energy storage. For whole of the day, size will be bigger. For whole of the year, this is the biggest energy storage system, because we have to design energy storage system and material in such a way. This is generally used for the generation of power generation or heating requirement of the whole of the year in industrial processing, for chemical industries, many pulp and paper industry, milk pasteurization, whole of the year energy requirement is there. So whole of the year there is storage requirement is also there, so that we can provide energy at the constant rate. You can see our whole of the year demand is constant, so we have to provide, and that's why we need energy storage for whole of the year. There are three kinds of small, medium and very large energy storage. So next is what are different kind of energy storage materials are there. And what is first one is that types of energy storage material. Types of energy storage material. So we can generally we can classify on the basis of temperature requirement. On the basis of temperature requirement, we can classify materials. Number one, low temperature, 0 to 100 degrees centigrade. So this is a low temperature requirement, mainly both kind of either liquid form or solid. Material will be available in liquid form or solid form. Water, paraffin wax, and similar kind of material, paraffin wax, and pebbles, rock. These are materials which can store energy from between 0 to 100 degrees. You know that water, boiling point of water is 100 degrees centigrade. So beyond that, it will be evaporated. So water is generally used for the energy storage. That comes under low temperature requirement, low temperature energy storage. So use of low temperature energy storage, I already said that this energy can be used for the water heating and room heating and chemical processing, sometimes high temperature, so low temperature, 0 to 80 degrees, between 50 degrees centigrade to 80 degrees centigrade. This temperature can be used for the milk pasteurization and chemical processing and pulp and paper industries and in cloth industries. Uh, process heating is required. That's why this kind of storage energy can be stored in these materials by using flat plate solar collector or evacuated tube collectors. And general thumb rule is that for 80 to 100 liter capacity of energy storage system 1 meter square area is required for the collector. For example, either we are using flat base solar collector or evacuated tube collector for energy storage up to 100 to 80 to 100 degrees centigrade requirement. 1 meter square is required for the 100 to 100 liter, 80 to 100 liter of the capacity of the energy storage. This is a thumb rule. Suppose we require suppose one cubic meter, 100 cubic meter is energy storage. So we multiply it. How much area will be required? We can calculate, because we know that for 80 to 100 liter capacity of energy storage for low temperature range 0 to 100 degrees centigrade, we require 1 meter square area of the collector. Collector is a source which provides energy to energy storage. It is a source which absorbs energy. We take energy from the sun or some other source and store it in liquid or any material, paraffin wax, rock wool, any material. It can store energy. So next one is a medium temperature. Second, medium temperature means 100 to 300 degrees centigrade. This is very high temperature. Only required for the medium type of energy storage system also. So for storing energy at these temperatures, some materials are there. These are synthetic oil. So USA brand is Downtherm A and Therminol. Second one is Therminol VP1. These are brand name. Of a synthetic oil. Third one is a Indian brand name, Servotherm. I think आप लोगों ने इसका नाम सुना होगा. We have heard this name, Servotherm. It is Indian brand name of the synthetic oil used for the energy storage. To store energy in range of 100 to 300 degrees centigrade, means to provide energy at this temperature, I think it is obvious that we can't use flat tray solar collector. We have to go parabolic cylindrical parabolic collector, because only cylindrical parabolic collector and some other collector, concentrating collectors, we have to use to provide energy at this temperature. So what is the problem with these? Because we can't go for very big energy storage system, because these are synthetical. First drawback. What are drawbacks? What are drawbacks of these? Drawbacks of these materials is that first is costly, because these are synthetic oil. Second one is degraded with time. Degradation rate is very high. Degradation means lost their capacity to store energy, means they lost their chemical constitution. Chemical structure will break, means degradation. Degradation with time. This is a major drawback. And third one, a degradation with time become very fast if temperature range is above the suggested range. If temperature range high, then degradation become very fast. Means suppose under given temperature range, it can work for 1 year. So if temperature range increases, then degradation may be within 1 month. If we are using temperature very high, देन गिवन टेम्परेचर रेंज से अगर हम हाई टेम्परेचर पर स्टोर कर रहे हैं एनर्जी को, तो वो डिग्रेडेशन बहुत ही फास्ट होगा. एंड फोर्थ प्रॉब्लम इज हाई सेफ्टी इश्यूज. What are safety issues? When if temperature rises above the flash point of the synthetic oil, then burning will take place. So highly hazardous. When flash point reaches, suddenly temperature rises and above flash point, burning will start. That's why these can be used only in environment having inert environment. That's why when there is a fluid flowing through the tube, we must provide concentric transparent glass tube having inert gas. Means there is vacuum inside the concentric glass tube that covered with the main tube line, or cylinder where it is stored. Means energy storage system where we store energy at this temperature. We must provide covering inert atmosphere to protect this storage tank, so that it will not burn due to flash point reaching. So that's why this type of energy storage are small to medium in size. For the power generation, we can't go to use these type of the energy storage. These are having inherent drawback, inherent properties, due to which we are not going to use. इनको हम बहुत ज़्यादा हाई टेम्परेचर में या बहुत बड़े बड़े एनर्जी स्टोरेज सिस्टम के लिए हम यूज नहीं करते, ओनली मीडियम साइज के एनर्जी स्टोरेज सिस्टम में इसको हम यूज करते हैं. थर्ड वन इज for power generation. For what material available for power generation? These are solar salt. Liquid solar salt are available, which are free from drawbacks that we have seen for the synthetic oil. So first solar salt is having that is a 40% NaNO2 and 7% plus 7% NaNO3 plus 53% KNO3. This combination is eutectic combination. This is eutectic combination means having sharp melting or solidification. Sharp, there is not varying melting point, but eutectic means sharp melting point. And this constitution of the solar salt, liquid solar salt, is known as high-tech. This is a commercial brand name, high-tech. This is available by name high-tech, and its melting point is around 145 degrees centigrade and range up to 425 degrees centigrade. We can use up to 425. This is a high range. It will melt at 145 degrees centigrade, and from 145 degrees centigrade to 425 degrees centigrade, we can use this solar salt for storing energy. Means once we store energy at this temperature, then we, by using heat exchanger water in combination with this solar salt, we can produce steam, and steam can be used for the generation of the electric power by running the steam turbine. That's why this material is useful for the power generation or some other high temperature application. So this is known as a high tech. Third one and fourth one is a one other brand name is available is solar salt. One is also known as solar salt. Brand name is solar salty, solar salt. Another combination of solar salt is 40. This is a 43%, around 43% NaNO2 and 57% NaNO3. This is known as solar salt. Its melting point 60% NaNO3 plus 40% KNO3, and its melting point is higher. This is a high temperature energy storage material. Its melting point is higher, and its melting point is higher and about 220 degrees centigrade and 220 degrees centigrade, 220 degrees centigrade, 220 degrees centigrade, and range 585 degrees centigrade. From 220 degrees centigrade to 585 degrees centigrade, this is range up to which we can use this solar salt for energy storage material, and this can be used for the generation of electric power and in heliostat type, means center receiver type, paraboloid disk collector type, because in these collectors, these energy storage system power plant, we can store energy in this solar salt. This is solar salt is a material in which we can this is a liquid material. After melting it become liquid, and in this liquid we can store energy up to this temperature, and this is a high temperature. For that temperature can be used for generation of power by this material. This liquid solar salt will move with one circuit, and water will move with another circuit, and the heat exchange will take place from liquid solar salt to the water, and it will convert into steam, and steam will be used for generation of power, generation of electric power, or we can use mechanical power for running the industrial system. So these are materials, and also other combination of materials are also available. These are not only fixed materials which are used. There are so many materials. The chemical energy storage system are also there, but they are still not mature to store energy in chemical energy storage system. Chemical energy storage materials based on the reaction takes place, and at absorption and reaction takes place when heat is extracting, but these are under development, still not mature enough to use at industry level. So these are major conventional energy materials, energy storage materials, which are used for the design and construction of the energy storage system and installation of the power plant. The next topic, that in which form energy is stored. So, what is a form of energy? In which form? Because material will store energy in form of number one, sensible heating, and second, latent heating, latent energy storage. In sensible heating system, material will remain in same phase. Q will be stored in sensible region, Q equal to mc S delta T. M is a mass of the material, Cs is a Cps is a specific heat, and delta T is a change of temperature. And latent heating will be when material will change its phase also from liquid to solid, from solid to liquid, then a temperature remains constant, M into lambda. Here lambda is latent heat. Latent heat. Joule, kilojoule per kg, because temperature remains constant. Here CPS is kilojoule per kg degree centigrade, because temperature is changing. So in two form energy can be stored in these materials: sensible heating and most of the material which are latent heating uh, materials have energy storage based on the latent heating energy storage system, also store energy in sensible heating. So we can define this formula how total energy is stored in sensible and latent heating. This is a very important formula: total energy stored. Total energy stored equal to m. M is a common because mass of the storage material is given. How much energy stored? T1 to Tm. Tm Tm to Tm, m T1 to and delta T dt, and Cp plus lambda plus CPL CPL integration Tm to T2. This is total energy stored and dt. Because temperature is changing, CPS is a specific heat of the material at average specific heat of the material at solid state, and this is a average specific heat of the material at liquid state. Because heating is take place first in solid phase once material start melting, then in latent form, and again material in latent when once it become liquid, then again temperature rises. So from Tm to T2. Simply we can, if temperature rise is finite, then we can simply write this equation m. If there is a finite temperature, Cps Tm to T1 plus lambda plus Cpl T2 to Tm. This is total energy stored in the M is a mass of the energy storage material in a container. CPS is average because when temperature changes, average specific heat will also change, because specific heat is become function of the temperature also. So whole of the temperature change, it may vary. So we take average specific heat of at solid state. So Tm is a melting point temperature, T1 is initial temperature, lambda, because once phase transformation start, temperature remains constant. That's why there is no unit temperature term. Lambda is a specific, lambda is a latent heat of energy storage. CPL is again once a whole of the material become liquid form, again temperature rise will take place in liquid state. So CPL during a liquid state, uh, especially heat of the liquid will also vary with rise of temperature. So we take average value, this average value, and now temperature rise will from Tm to T2. So total energy now we stored, that is a, you can say Q. This is a Qs liquid state plus lambda m and plus Q liquid state QL. This is total energy, solid state, and during phase transformation, latent heat lambda into m and QL in liquid form. So this equation is very important, and I know पिछले साल 2025 में एक IES में क्वेश्चन आया था 20 नंबर का, 20 मार्क्स क्वेश्चन आया था, केवल इसी पर बहुत सिंपल क्वेश्चन था, कितना मास चाहिए एनर्जी को स्टोर करने के लिए. टेम्परेचर रेंज वाज गिवन and the latent heat was given and the specific heats was given. We have to calculate what is requirement. This was given, suppose 2 megajoule, 3 megajoule was given, and m we have to calculate m. Anything we can find out. अगर आपको ET दिया हुआ है और ये बाकी सारी वैल्यूज दी हुई है, T1 Tm दिया हुआ है, T2 दिया, T1 टेम्परेचर रेंज दिया हुआ है, मेल्टिंग पॉइंट दिया हुआ है, लेमडा दिया हुआ है, then you can find out m. Mass of the energy storage material required to store that amount of energy. I think this this topic is interesting and it is now clear. आपके ये simple भी है, वो आसान है, clear है. Next time we will come here again to interact with you and we will define thermal analysis of the liquid storage tank, liquid based energy storage tank, thermal analysis, means temperature distribution, how temperature distribution will takes place when energy is coming to the storage tank and energy is also delivered to the load. So what will be a variation of temperature of the energy storage tank? That is thermal analysis, and we will find also efficiency versus time, temperature variations in next lecture. Thank you very much and have a nice day. Please.